Chapter 5 Continuous Beams and Slab. In this chapter, we're going to introduce you the design of continuous pre-stressed concrete member. We are not going to cover in detail all the aspects, as some of the basic concepts has already been discussed in the previous chapters. Due to the constraint of the durations for the course, as well as to minimize the redundancy, these chapters will focus on the introductory level and will only highlight some unique characteristics of a continuous member which we need to pay attention in terms of the design. For more details, you may refer to the references for the pre-stressed concrete design that I have mentioned of in the early of the course. Without further ado, let us get started. First, we need to know the differences between the simply supported and continuous member. The simply supported members are normally referring to one span, while the continuous members have the span more than one. In terms of the analysis, shear force and bending moment diagram, the simply supported member is relatively easy. You can use the principle of static equilibrium for you to determine the reactions. Based on the reactions obtained, you can develop the shear force and bending moment diagram. The typical bending moment diagram for a simply supported beam is given here. As for the continuous member, there will be more than one span, and in terms of the analysis, it is basically an indeterminate member, which you can use the force method from the structural analysis for you to reduce the redundancy so that you can find the reactions by using the principle of static equilibrium. You may also use the moment distribution methods in order to analyze the reactions in the member, as well as to determine the shear force and the moment in the member. Bear in mind that when we need to do the analysis for the continuous member, there will be a series of load combinations under different configurations of the maximum and minimum loads. From there, you need to develop the envelope shear force diagram and bending moment diagram in order for you to find the most critical loads applied onto the member. You know that the design of the pre-stressing member always starts with serviceability limit state. Under such circumstances, you will use the factor of safety of 1.0. Then when you come to the design of the moment and shear and even torsion, those are classified under ultimate limit state. Then you will have to have the factor of safety of 1.35 and 1.5. In terms of the effects of the pre-stressing force, there will be no restraint for the simply supported member. That means this pre-stressing force will not impose additional strength, which is contributed by the reaction. However, for the continuous member, there will be redundant supports that can impose additional geometrical constraints, such as zero deflections at the intermediate support, which when you apply the pre-stressing force, the member supposedly to bend outward now is resisted by the redundant support here, resisting the upper displacements of the member, and this has induced additional stress in the member. Under some circumstances, there could be some prescribed non-zero settlement. This will add in the additional stress in the member, or some circumstances, the ends or the connections of the members impose some restraints to the bending rotations that can give zero slope to the member, which is resisting the bending deformations caused by the pre-stressing force. Such resistance will impose additional stress in the member. During stressing, the geometrical constraint may cause additional reactions to develop at the support. This in turn changes the distributions and magnitude of moment and shear in the member. With that said, pre-stressing a continuous member by fundamental will be more complicated as compared to the simply supported member. This slide shows the advantages and disadvantages of the continuous span. In the context of the pre-stressing member, first, the continuous span normally have a smaller magnitude of moment and deflections. This is mainly due to the characteristic of the member that can distribute stress to the adjacent spans. Second, if you're doing pre-stressing on the continuous member, fewer anchorage will be required. One continuous tendon may stretch between several spans, and the number of the anchorage may be reduced significantly. This will also reduce the labor cost for the stressing operations. Another advantage of the continuous span is its joint rigidity, where there are resistance to the lateral loads like wind, blast, and seismic forces. The entire member serves as a continuous unit. The excessive lateral load acting on the member can easily be distributed to the adjacent panels, and this provides additional resistance to the lateral load. As for the disadvantage of the continuous member, the moment can vary greatly along the length, and this often leads to uneconomical design. However, this in some way can be overcome by adjusting its P and E along the member, as this leads to additional considerations in the member. The analysis process and the proposal of the PME will be more tedious. Also, the continuous span are normally associated with large frictional loss due to the several change of the curvature in the tendon profile. If you see our example in the previous chapters, frictional losses is one of the significant short-term loss that you can obtain from a post-tension member. Such losses will affect the efficiency of the pre-stressing tendon, which at the end of the day, we are unable to fully utilize the capacity of the tendon. When you come to the continuous member, the spans are normally longer, and there are several turning points of the curvature in the tendon profile. This will in another way increase the frictional losses and further affect the efficiency of the pre-stressing tendon.